Hi everyone. In today's video, I will be going over the Q4 benchmark review for your benchmark next week. One thing I want to say, just a warning ahead of time, this is 27 problems long, so as you can imagine, this video is going to be lengthy. I apologize in advance already, but let's just get started and get done as quickly as possible. So on the front page, this is Unit 8A, simplifying fractions and multiplying and dividing fractions. It's a lot of combining, a little bit of actual multiplication, and a lot of factoring as well. So just keep your head up for that. So number one, we have 3x squared plus 9x over x plus 3. When they ask you to simplify, we're going to do two things. We're going to factor, if you can, and reduce. When they say simplify specifically, we'll be reducing as well wherever we can. So in this fraction, I've got one thing I can factor, and that is the 3x squared plus 9x. So let's take care of that real quick. So if we look at this squared is kind of a big hint that you can factor this. There are four types of factoring problems that we discussed. There is the GCF, the difference of squares, and two types of trinomials, one with a number in front of the x squared and one without. Now this clearly only has two terms. It's not a trinomial. This is not a difference of squares. A difference means subtraction. We are adding here, so that's reason number one. Reason number two, you can't square root of 3. It will not be a nice number. So the only option left, if it's not a difference of squares, it is more than likely a GCF problem if it can be factored at all. And so this says have a GCF. Let's first look at what we can divide both of them by for the numbers. 3 and 9, you can divide both of those by a 3. And then they both have an x on it. That means you are also able to divide both of them by an x. Now we're only going to do one x because I can't do x squared. That will be too much to take out of 9x. So you take the smaller number of x's out, so just one. When we do that, one of the big rules of GCF that a lot of you forget about is you pull the GCF out. It doesn't just divide out and disappear. It comes out in front, and then you put what's left over in the parentheses. So when I do that, the 3's are going to cancel. And then we've got x squared over x. Remember, this is like a subtraction. 2 minus 1. We're left with just an x plus, on the right side, these x's will cancel because there's one of each of them. And then 9 divided by 3 is 3. So that is how this factors. And then we look at our denominator, x plus 3. We can't factor that. There's nothing to do with it. So I'm going to bring this down. This becomes 3x times x plus 3. I replaced it with what I just factored on the top over x plus 3. Now this is multiplication we're doing here. This is like 3x times this. So this is when we are allowed to cancel. And notice that these are separated by parentheses. And we can see inside of those parentheses we have the exact same thing. This is why we can cancel. Those cancel, and we are left with just a 3x. Number two, same thing. X squared minus 5x minus 24 over 2x minus 16. We can actually factor both the top and the bottom. Let's start with the top. X squared minus 5x minus 24. This is a trinomial. That means there's three terms. No number in front. Those are my favorite. So I just need an ACB chart to solve this. And then we will write out our factors once we figure out what they are. So A is 1, we look at C, that's negative 24, and B is negative 5. 24 has a lot of factors. You've got 1 and 24, 2 and 12, 3 and 8, 4 and 6. I believe that's all of them. The pair we need here to get a negative 5 are 3 and 8. And to get negative 5, we'll have to do some kind of subtraction. Since we want a negative 5, the bigger number has to have the same sign as B, so it must also be negative. The bigger number controls what this number looks like. 3 minus 8 is negative 5. That works. And then don't forget to do a quick Just ask yourself, is 3 times negative 8 negative 24? Yes, it is. Always just do a quick check for that, because sometimes the adding works, but not the multiplying. X plus 3, x minus 8. That is how that factors. So on top, we now have x plus 3, x minus 8. And then we can factor the bottom as well. 2x minus 16. You may miss it at first because it's just an x term here, but 2 and 16 you should pick up on something right away. Those are both even numbers. That means I can divide both of them by a 2. No x's because 16 doesn't have an x. So we pull out the 2, bring it out here, and then we divide. So the 2's are going to cancel here, and we just have an x minus 8. So that's going to go on bottom. So we factor the top and the bottom. Now let's see what we can cancel. In parentheses on top and bottom, I do have an x minus 8. So those are going to cancel. And now I have x plus 3 over 2. And I always encourage you to put parentheses around these little expressions here so we don't cancel anything we're not supposed to. That's our answer. There's nothing else we can do with that. Number 3, more factoring, more reducing, and more canceling, but multiplication now. So these are just basic numbers. Notice there's no expressions. And in an expression, we had these are 4 different expressions here. They are multiple terms linked together by addition or subtraction. Here in number 3, we have what we call monomials. They are one term, and they're joined by multiplication. So it just looks like one thing put all together. So for these problems, we're going to actually be multiplying a bit. So what we want to do is just first turn this into a single fraction, and then we'll reduce from there. So on the top, remember when you multiply straight across top and bottom. We have just a 20, and this is like a 1 over here, so it's just become 20 on the top. And then we have x's on top of both fractions. Now remember, when you multiply the letters, the same letter, you are adding the exponents. So this is actually going to be x to the 2 plus 5. Make sure you are not doing 2 times 5. It's a very easy mistake to make. And then y to the 5th times y cubed. Again, we are multiplying the y's, but adding the exponents. That would be to the 5 plus 3 power. And then we'll repeat that on the bottom. Once again, the only number down here is a 4, so I'll bring that over here, put it in front. And now I got the x's. And be careful, this is an x to the 1st. So then when I multiply, I have x to the 1 plus 3. And then I just have a singular y, so I'm going to bring that down. So from here, I can reduce this now, or I can wait. I'll just wait. I want to get these together first. 20, x to the 7th, y to the 8th, over 4, x to the 4th, and then just a y. Now from here, we're going to simplify, cancel things, do what we need to do. Let's start with our numbers. 20 over 4, I hope you recognize that. 20 divided by 4 is 5. So this 20 will turn into a 5, and this 4 will turn into a 1, so it's going to disappear. Now, we are dividing the same letter. When you divide the same letter, you subtract the exponents. So, and you subtract where the bigger exponent is. So we have x to the 7th on top and x to the 4th on bottom. So I'm going to take 4 from the 7 up here, and now I'm going to cancel this out. It's gone. And then reminder, this on the bottom is y to the 1st. 8 on top, 1 on bottom, we'll subtract from the 8 on top, 8 minus 1. So that's going to be gone as well. So notice the entire denominator has been canceled. So this will no longer be a fraction when it's all said and done. So we have a 5 in front. And then we have x to the 7 minus 4, that's x cubed. And then y to the 8 minus 1, that is y to the 7th power. No denominator, it all disappeared. It is just now over 1, so we don't have to write it. And there's my answer. Number 4. More of that, but we're starting with division. Now remember, when we divide fractions, we're going to turn it into multiplication. The rule when you divide fractions is keep, change, flip. Keep, change, flip. So we're going to keep this fraction the same. We have 5ab over c. Change this to multiplication, and then we're going to flip our second fraction. So we have 10b cubed a over 2a squared c. And now this is just like number 3. We're going to multiply straight across first, and then we will simplify where we can. So multiplying straight across, we've got numbers now. We have 5 and 10. 5 times 10 is 50. And they try to trick you here by putting the a and the b out of order in the second fraction, but you're not going to fool us. We've got 2 a's here. And these are both a to the first. So remember, when I multiply, I'm adding the exponents. A to the 1 plus 1. And then we have we have a b, it's just a b, so b to the first, and a b cubed. So b to the 1 plus 3 on top. Now for the bottom, we just have a 2, so we're going to bring that over. And then we have just a lonely a squared, I'll bring that over. And then I've got 2 c's, both to the first power, so that's c to the 1 plus 1. Let's rewrite that with the exponents now. 50 a squared b to the 4th over 2 a squared c squared. And now we cancel. Cancel, reduce, whatever you want to call it. 50 over 2, 50 is even, so you can divide it by 2. It is 25. So this 2 is going to disappear entirely and become a 1. A squared on top and bottom, they are exactly the same, so they fully cancel. So the b to the 4th and the c squared, they are different letters, so I can't reduce them. They are going to stay as they are. I'm going to put that all together. So on the top here, I still have a 25. Don't forget about that. A squared is gone. I still have a b to the 4th. I'll bring that down. On the bottom, the 2 is gone. It's now a 1. A squared is gone, and I still have a c squared, so I'm going to bring that down. And I'm all done. Number 5. Multiplying. So we're going to multiply, factor, do all of it first. So it's actually helpful to start by factoring what you can. You have everything separated. This makes things kind of nice. And then we'll put it all together and cancel at the end. So let's start just by factoring. Let's look at our first fraction. We have x plus 3 over 10x plus 20. X plus 3 can't be factored, but 10x plus 20 can be factored. So let's start there. Again, you need to look for these things. This is not a difference of squares. This is not subtraction. This is just an x. It doesn't work like that. So the only other thing it could be is a GCF. 10 and 20 both have a number in common. Again, you want the largest number in common, and that's 10. So we're going to divide both of them by a 10. 10 comes out completely. It doesn't just disappear. These 10s will cancel, so we'll be left with an x in front, plus 20 over 10, that's 2. So my first fraction, I have x plus 3 over 10 times x plus 2. We're going to start there. Times, and then we've got some factoring to do here. So let's go through and do that. X squared plus 7x plus 10. Trinomial, we've got 3 terms here, no number in front, my favorite, so all we need is an ACB chart. A is 1, so we look at C, that is 10, and B is 7. This one's not too bad. 10 only has 2 pairs of factors, 1 in itself, 2 and 5, and clearly 1 and 10 are not going to give us a 7. 2 and 5 will. When they're both positive, they do equal 7. And 2 times 5 is 10, so we're good. Everything matches up. So my factors are x plus 2, x plus 5, and then one more time, our bottom, we have x squared plus 4x plus 3. This one factors very nicely because we don't have many options for what it could be. This one's very quick to factor. 3 terms, no number in front, ACB chart to get it done. A is 1, so we look at C, that is 3. B is a 4. 3 only has 1 pair of factors, 1 in itself, and 1 and 3 do give you 4 when added. So we're good. Those are my factors. X plus 1, x plus 3. Now, when we go to multiply, and let me for clarity put parentheses around this x plus 3 up here. When we have expressions, we are not going to actually multiply these together. Remember, if we wanted to multiply these, we would be foiling, and that would be a lot of work. The goal is to cancel things out. If we start multiplying and putting things like foiling and doing all that math, that's going to make that goal very difficult to achieve. So when we multiply expressions, it's going to look exactly as these two on top do here. They're going to be next to each other. This is still multiplication, but we're not going to actually do the math, if that makes sense. Just put them all together into one fraction. So that's exactly what I'm going to do. So I'm just going to bring all these down. X plus 3, x plus 2, x plus 5, 10, x plus 2, x plus 1, x plus 3. Make it very easy on yourself here. So again, this is still multiplication. I just didn't actually multiply out anything. I don't want to. Now we just look for pairs of things that can be canceled. X plus 3 on top and bottom, gone. X plus 2, top and bottom, gone. That's it. These two are different, and I don't have any numbers on top to reduce with the 10. No, we are not reducing the 10 with this 5. This is x plus 5. This is just a 10 by itself. That's a no-no. So now we will write our final answer. On top, we just have x plus 5. On bottom, we have 10 times x plus 1. That's it. Number 6. Once again, another multiplying problem, so we'll go in and factor these, as many as we can. I hope you're starting to recognize these. These are all for the same type of problem. They are not trinomials, so that leaves two options, difference of squares or GCF. They are not difference of squares. First off, we just have n, not n squared. And second off, these are all being added, not subtracted. These are all for GCF problems. So we have 5n plus 15. What do they both have in common? A 5. You pull a 5 out, take it out. 5's cancel, n plus 3. 5 times n plus 3. Next, we have 4n plus 8. What do they both have in common? 4. You can divide both of them by a 4. 4 comes out. 4's cancel. N plus 2. Oh. Two more. 2n plus 4. What do they both have in common? 2. You can divide them both by 2. 2 comes out. These 2's are going to cancel. N plus 2. One more, 3n plus 9. What do they both have in common? 3. Divide both of them by 3. Cancel. Oh, I almost forgot. Bring the 3 out, and then 9 divided by 3 is 3. 3 times n plus 3. Now that I've factored all of these, I'm going to first multiply, so put everything together, and then we'll cancel. Now when we have actual numbers involved, out in front like we do there, we will multiply these. So 5 times 2, that's 10. And then we're just going to bring these down. N plus 3, N plus 2. And then on the bottom, 4 times 3, that's 12. N plus 2, N plus 3. Ten over 12, those are both even, so we can reduce it. We won't be able to fully divide, but we'll be able to get it smaller. You can divide both of these by 2. So 10 divided by 2 is 5, 12 divided by 2 is 6. And then we have n plus 3 on top and bottom, gone. N plus 2 on top and bottom, gone. So our answer is actually just 5 over 6. That's it. Page 2. More of the same old, we're just kicking up the difficulty up a bit. 5x squared plus 21x plus 18 over x minus 4 divided by 15x plus 18 over x squared minus 16. First, we have division. When you have division, you're going to keep, change, flip. So let's do that first before we forget. 5x squared plus 21x plus 18 over x minus 4. Change to times x squared minus 16 over 15x plus 18. Now we're going to factor. Let's start with the big one over there. 5x squared plus 21x plus 18. This is a trinomial. That means it has 3 terms, and it's not the greater kind. It has a number in front, and I can't pull that 5 out. I can't divide either of these by 5. So that means we are going to have to slide and divide. So I have 5x squared plus 21x plus 18. First we slide that 5 over to the 18. ACB chart to find our factors. I'm going to go ahead and set these up. 5 times 18, and I did not give myself nearly enough room, and I honestly won't have room with the space I'm given, so I'm going to do this on a Post-it note anyway. These factors actually took me a moment to find when I was doing this myself. 5 times 18, I'm going to check, I believe that's 90. Yep. So A times C, that's 90, and B is 21. Now I'm going to go through these on here, and then I'll write the final pair here. Okay, 90 is a big number, so it has a lot of factors. So we have 1 and 90. We have 2 and 45. Those are kind of the obvious ones. 3 can go into that, 3 and 30. Now we're still not remotely close to 21. This would be 91, so that's not what we're looking for. Oh, did not look good. That's better. 2 and 45, that's going to give us 47. Nope. 3 and 30, that's going to give me 33. Nope. So we got to keep looking. Now I'm going to keep going up on the left side. That's going to make it easier. We'll start with the smaller numbers and work our way up. 9 and 10 is another obvious pair, but I hope you could tell that's not going to work. 9 and 10 will be 19. So now we just start trying different numbers. Let's see if 4 goes in there. 90 divided by 4. Nope. It ends in 0, so I know 5 can. And actually, I just did that math. That's how I even got 90 in the first place. 18 and 5. And when I add those, that is 23. So still no. Okay, let's try 6. 6 and 15, let's try that. 6 and 15 do equal 21. So 6 and 15, that's the pair I need. And again, both positive. They will give me a positive 21. And then we already do know 6 times 15 is 90. So we're confident in that. So this is x plus 6, x plus 15. Now don't forget, this is the easiest part to forget about slide and divide. First we slide, then we divide. So we slide by the 5, now we divide by the 5. Let's make our final answers. 6 can't divide by 5, so we're going to slide it in front of the x. So this is 5x plus 6. And then this does divide. This is x plus 3. So finally, I can rewrite this fraction as 5x plus 6 over x plus 3. And then on the bottom, I will bring down that x minus 4. That can't be factored. Times x squared minus 16. I hope you recognize this type. Here we have a minus in the middle. That's difference. We're subtracting. And 16 is a perfect square. So this is a difference of squares. So we square root the front, square root the back. And remember, we make 2 factors, not 1. So square root of x squared is just x. Square root of 16 is 4. And we have to have a plus and a minus. You got to have both. Lastly, the 15x plus 18. I hope you recognize that. Not a difference of squares. Now that we have both types in the problem, I hope you can clearly see the difference between the two. Just because it's 2 terms doesn't make it a difference of squares. First off, we're adding. Case closed there. So 15 and 18, ask, what can I divide both of these by? Surely there is something. 3. Pull out the 3, don't leave it behind. 15 divided by 3 is 5, and then the x plus 18 over 3, that is a 6. So here we have 3 times 5x plus 6. Now from here, let's make this one fraction. And I'm running out of room here, so I'm going to have to be a little cautious. So I have 5x plus 6. And again, these are all expressions. That's why they're in parentheses. So just put them all together. X plus 3, x plus 4, x minus 4. So I put all the top ones together, and now the bottom ones. Oh, I forgot about this number, this 3. Just so it's not awkward, put the 3 in front. And then the expressions, any order. X minus 4, 5x plus 6. The only thing we have left to do is cancel. I have a 5x plus 6 on top and bottom, gone. X minus 4, top and bottom, gone. That's it. Let me re-clarify. This 3 and this 3 do not cancel. This 3 is in parentheses with an x attached to it. This is how mistakes are made. So this is not x plus 3. This is x plus 3. So we can't cancel like that. So don't cross those out. We have done everything we can. So our final answer is x plus 3, x plus 4, all over 3. And that is all we can do. Number 8. A to the 4th plus a cubed minus 20a squared over a squared minus 16 divided by 2a squared plus 7a minus 15 all over 4a squared minus 6a. First off, we have division, so again, keep, change, flip. A to the 4th plus a cubed minus 20a squared over a squared minus 16, change to times 4a squared minus 6a over 2a squared plus 7a minus 15. We have some work to do. So, we're going to start by factoring the top over here. We have a to the 4th plus a cubed minus 20a squared. Now, some students ignore the fact that these exponents are higher than they should be, and they just factor this trinomial. You can't do that yet. We can't do that if we got an a to the 4th. So, hopefully you notice every term in here has a's, so we can factor out some a's before we get started. This at the beginning is a GCF problem. We can divide all of these by, you take out the smallest number of a's, a squared. So, a squared is going to come out. And then this is just subtraction. 4 minus 2, we're left with a squared. 3 minus 1, we're left with just an a. Minus 20, and then these a squareds are going to cancel completely. So, that is what this looks like. Now I can factor the trinomial. It's in the correct order. It has the correct exponents. We are good to go. So, we have a squared. You bring that down. I'm going to factor this, so I'll have my two factors in a moment. And then ACB charts to get my numbers. So when we're doing this, we're just looking at what's in the parentheses. The a squared is just coming along for the ride, so we ignore that for a moment. A has a 1 in front of it, but a literally is 1. So 1 times negative 20, that's negative 20. And b is positive 1. 20 has a few pairs of factors, 1 and 20, 2 and 10, and 4 and 5. To get a 1, we're going to use 4 and 5. Now clearly we're going to need to subtract them to get that 1, and we want a positive 1. So that means the bigger number has to be positive, so the smaller number has to be negative. If 5 has to be positive, 4 has to be negative. Because if we want a negative 20, one of them has to be negative. And then negative 4 plus 5 is still positive 1, so that works. So, on our first fraction on top, hang on, I didn't fill this out, minus 4 plus 5. So I'm going to replace it with that. A squared times a minus 4, a plus 5, over a squared minus 16. We literally just did this in number 7, except with x's. This is a difference of squares. We have the a squared in front, 16 is a perfect squared, and the key we are subtracting here. Square root the front and the back. Square root of a squared is a. Square root of 16 is 4. And we have to have the plus and the minus. Times. I will definitely be using a Post-it note to finish this problem because I don't have enough room to fit both of these factorings over on the side. All right, 4a squared minus 6a. There's an a squared, so that means we can factor something, some way, somehow. Now, this looks like a difference of squares because it has a minus. 6 is not a perfect square. If you try to square root it, it's not going to be pretty. And we only do perfect squares with this. So if it's not a difference of squares, it's a GCF. 4 and 6, those are both even, so let's divide by 2. And they both have a's. We're taking out the smaller number of a's, so just a. 2a comes out. And then we're going to cancel what we can. 4 divided by 2 is 2. A squared over A, this is just subtraction, so we're left with just A minus 6 over 2, that's 3. And the A's are going to cancel. Now I'm going to replace that on top of the second fraction. 2A times 2A minus 3. And then I'm going to get a post-it note to factor my last set here. So we have, I was looking at the wrong part, sorry, 2A squared plus 7A minus 15. We got a 2 in front of our trinomial here, and we can't take it out because these are odd numbers. So this is slide and divide. So we do 2 times 15. ACB chart. 2 times negative 15 is negative 30, and my B is 7. 30 has a few factors, but not too many. 1 and 30. 2 and 15, which so far, I'm not going to get a 7 out of either of these. 2 and 15, that's 17. If I subtract, it's 13. 3 and 10. Now 3 and 10 can give me 7. I'm going to have to subtract, which I need to anyway. That's the only way to get negative 30 when I multiply. Since my B is positive, my bigger number 10 must also be a positive, so my 3 is negative. Negative 3 times positive 10 is negative 30. That works. And then negative 3 and positive 10 give me positive 7. So those are my factors. Now let's set this up. X minus 3, x plus 10. Now I put this right under here so we remember when we slide, we also have to divide. So come back in and divide by the A value, which was 2. This can't divide evenly, so I'm going to bring that 2 forward. 2x minus 3. And then 10 divided by 2 is 5. X plus 5. And that is how this factors. 2A. I knew I was going to do that. Hang on. These are A's. 2A minus 3. A plus 5. All right, we have done most of the work at this point. Just a couple more steps. First, let's put it all together into one nice big fraction. First off, we have some terms in front that are by themselves or not in an expression, so we can multiply these. So we have 2A, and then remember when we multiply letters, we add their exponents. This is 2 plus 1. And I'm going to bring all of these down. A minus 4. A plus 5, 2A minus 3, over, I'm just going to bring all these down. A plus 4, A minus 4, 2A minus 3, A plus 5. And now my favorite part, the canceling process. So I have an A minus 4 on top and bottom, those are gone. A plus 5, top and bottom, those are gone. 2A minus 3, top and bottom, those are gone. So I'm left with 2A to the, this is going to be the third power, over A plus 4. And I'm going to have to write a little smaller here, so forgive me for that. 2A cubed over A plus 4 is my final answer. And that's it. Number 9. X squared minus 25 over x plus 6 divided by 2x minus 10 over x squared plus 5x minus 6. So this is another division problem. Remember, When you have a fraction over a fraction, this is still division. So we are going to keep, change, flip again. So I have x squared minus 25 over x plus 6 times, we're going to change that to times, and we're going to flip the bottom fraction. X squared plus 5x minus 6 over 2x minus 10. Now we factor. X squared minus 25, I hope you recognize that. We have a minus, so we do have a difference. 25 is a perfect square. Its square root is 5, and then we have the x squared. So this is a difference of squares. Square root of the front and the back. 2 factors. Square root of x squared is x, and then square root of 25 is 5. We have a plus and a minus. X plus 6 can't be factored, just bring that down. Times x squared plus 5x minus 6. I'm going to do a little less side work as I keep going. Hopefully with each problem it gets easier and easier. This is a trinomial. We have 3 terms, so I know they're going to factor. So I'm going to do more of my work in the fraction, is where I was going with that a moment ago. ACB chart to get my answer here. A is 1, so we get C, that's negative 6. B is positive 5. Now be extra careful with these specific numbers. These lead to mistakes all the time because there are a couple options we have. So I'm going to write out both factors of negative 6. 1 and 6, 2 and 3. Now most students will incorrectly put 2 and 3 down because that gives me 5, but 2 times 3 is not negative 6, it's positive 6. So these are not my factors. I need a negative 6. So I'm actually going to do 1 and 6. And since I need a positive b, a positive 5, the bigger number, the 6, has to be positive. 6 minus 1 is 5. And negative 1 plus 6 is negative 6. So this is one of the ones I'm talking about where we can add 2 and 3 and we'll get 5, but it won't give us the right answer up here. So you need to check both. So we have x minus 1, x plus 6, and then the 2x minus 10. We have subtraction, yes, but this is not a difference of squares. I hope you recognize that. So you look and ask yourself, what do they both have in common? They're both even. Divide them both by 2. 2's cancel. And don't forget to bring the 2 out like I just did. X minus 5. All right, so let's put this into one big cozy fraction here. X plus 5, x minus 5, x minus 1, x plus 6, all over. We have a 2 that's all by itself. It's going to come out in front. 2 times x plus 6, x minus 5. And then we cancel. So x minus 5, top and bottom, those are gone. And then we have an x plus 6 on top and bottom. Those are gone. That's it. All the others are by themselves. So we're going to make our final answer with those terms. We have x plus 5, x minus 1 over 2. And that's it. Number 10, we're going to do that one more time before we switch to a different type of problem. So here again, we got a fraction over a fraction. That is division still. We're going to divide, so we will keep, change, flip. So I have, I'm trying to figure out the best place to write this. I think over here would be actually better for this problem. X minus 4 over x squared plus 6x plus 9. Change to times, flip, x squared minus 9 over 7x squared minus 26x minus 8. All right, factor. First fraction. That x minus 4 will stay. Can't factor that. On the bottom, x squared plus 6x plus 9, this is a trinomial. No number in front, which is the best kind. So I just need an ACB chart. A is 1, C is 9, B is 6. 9 only has 2 pairs of factors. 1 and 9, 3 and 3. Clearly 3 and 3 will give me a 6. Positive 6 at that. And 3 times 3 is positive 9. So it works both ways. So over here we have x plus 3, x plus 3. If you use the same number, you do write it twice. Times x squared minus 9. I hope you recognize this. This is a difference of squares. We're subtracting, and 9 is a perfect square. Square root of x squared is x. Square root of 9 is 3. And we need a plus and a minus case. Lastly, we've got this doozy over here. 7x squared minus 26x minus 8. And this one's going to be extensive, so I am going to go ahead and do this on a Post-it note again. Oh, and by the way, we can't take the 7 out. If I could, I would. 7x squared minus 6x minus 8. So clearly we're going to have to slide and divide here since we have a trinomial with a number in front. So we will slide 7 times negative 8. I'm going to go ahead and set up my factors. Get myself prepared. ACB chart. 7 times negative 8, that is negative 56. B is negative 26. 56, it's a bit larger of a number, so it does have a few factors. Not too many, but enough. So we're going to have to experiment a bit. 1 and 56, and clearly that is not going to get us a 26, not remotely, so we can go ahead and cancel that out. It's even. 2 and I think it's 23. I don't know, that's not right. 28, there we go. 2 and 28. Now, if I subtract these two, I can get a 26, and that's my goal. Now, since it says negative 56, I do need one of these to be negative. And since I need a negative 26 when I add, the bigger number is going to have the same sign, so this will be a negative 28. 2 minus 28 is negative 26, so that works. And again, just a quick check, 2 times negative 28 is negative 56, so we're good on both fronts. So those are my factors, x plus 2, x minus 28. And again, I intentionally set this up this way so we remind ourselves when we slide, we must also divide. Divide by 7. 2 will not be divided by 7, so we're going to bring that in front. Because I just messed that up. 7x plus 2. And then x minus, this is 4. And these are my factors. This process, once you do it enough times, really isn't bad. It's just tedious. Okay. Now we put everything together and we cancel things. Top, we've got x minus 4, x plus 3, x minus 3. Bottom, x plus 3, x plus 3, 7x plus 2, x minus 4. And now the fun part, canceling. X minus 4, top and bottom, gone. X plus 3, top and bottom, gone. Now we got 2 of them. We have to make pairs. So if I cross out 1 on top, I cross out 1 on bottom. This one is still there. And since these are opposite signs, these will not cancel. And I don't have another 7x plus 2. So this is my answer. X minus 3 on top, X plus 3, 7x plus 2 on the bottom. All right, we are done with those types of problems. 11 and 12. I know that these were not a favorite. So, solve. 4 over x plus 3 equals 2x over 3x plus 9. When we do these problems, it is important that you have a common denominator. So if you haven't looked fully through the study guide, you'll notice that we did not include problems with adding and subtracting questions in here. That's from A to B. A lot of you struggled with that lesson more than the problems we just did a moment ago. So for that reason, we didn't include it, but we did include these problems, which were on that test, the equations. And you still have to get a common denominator to do those problems. Now, number 11, I'm sure some of you will look at this and notice, hey, I can cross multiply that. You absolutely can. I will warn you. If you cross multiply, you will end up with an x squared, a quadratic, and that means you will have to factor. If you're okay with that, go for it. That is not what I'm going to do. So, let's figure out what our common denominator has to be. Remember, that is called the LCD. When we look at our current denominators, we have x plus 3 and 3x plus 9. What you want to do is see if you can factor either of these. I clearly can't factor x plus 3, but I can factor 3x plus 9. This has a GCF of 3. You can divide both of them by 3. So the 3's will cancel, giving me x plus 9 divided by 3 is 3. And I could easily turn this fraction, this denominator, into that. It just needs a 3 given to it. So that is my LCD. 3 times x plus 3. Now, before I get any further, one big thing you need to remember about these problems is you have to check, because when you have a fraction, we can't end up with a 0 on the bottom. So we have to see what values of x would give us a 0. So, one thing I'm going to do real quick is I'm going to set any letters equal to 0. So the x plus 3, that gets set to 0. The 3, it's whatever, it's just there. X plus 3 equals 0. If I subtract 3, I get x equals negative 3. So when x is negative 3, I will get a 0 on the bottom of my fractions. That is not okay. So x cannot equal negative 3. I just need to keep that in mind. So reminder, I'll go through and solve my problem like normal, and if I get this as my answer, it will actually be a no solution. If I don't, no harm, no foul. All right, now that I have checked, kind of carve this out here. Now that I've checked, I can go about the problem like normal. So I want this denominator to look like this one. The only thing that it's missing is the 3. So all I need to do is multiply top and bottom by a 3. When I do that, I will get 4 times 3, that is 12. And then on the bottom, I get 3 times x plus 3, don't actually multiply them together, equals 2x over, I'm going to put the newly factored denominator, 3x plus 3. So this is where I'm at. Now that I have the same denominator, I'm good. And remember, the goal here is to solve this equation. If I have the same denominator, I can basically drop it. So I'm going to take my equation here, and I'm going to solve it. So now I am just looking at 12 equals 2x. I have dropped the denominators. Since the bottoms are equal, the tops must also be equal. That's the logic here. And this becomes a very quick problem. Divide by 2 on both sides. X is 6. And I did not get negative 3, so I'm good. That wasn't too bad. One more. Number 12. Here we have multiple fractions, and again we need the same denominator. Let's identify that LCD. So we look for a denominator that can be factored, and we have this over here, x squared minus 6x plus 8. It's a trinomial, 3 terms, so we're going to factor it. We've got our x's. No number in front, so that makes it easy. Now, we need to come up with our factors. 9 times out of 10, one or both of these are going to give us this answer. And so let me set up an ACB chart and see if those two numbers work. So A is 1. So we look at C, that's positive 8. B is negative 6. Now, if my hunch is correct, my factors are going to be negative 4 and negative 2. If I add these, I do get negative 6. And if I multiply, they still come out to be a positive 8 because a negative times a negative is still positive. So these are my factors. So I use the other denominators to basically give the answer to me. So that helps. So here are my 3 denominators. I can definitely make both of these fractions over here look like this one. I just have to give them each other the expression they're missing. So my LCD is x minus 4, x minus 2. And before I go any further, I have to check. So I'm going to set both of these equal to 0. And again, I'm checking for answers that are not going to work. So if I add 4, I'll get 4. And if I add 2, I will get 2. Sorry that these are a bit squished. So these are the 2 numbers that will give me a 0 on the bottom of a fraction. So I need to just be aware of that. So x cannot equal 4 or 2. I just need to keep that in mind when I solve this problem. I can't have either of these. Okay, let me block this off. All right. Now that I've dealt with that, I can get the same denominator and then solve my problem. So I have 1 over x minus 4 plus, and I didn't give myself much room, plus 3 over x minus 2 equals 2 over the newly factored denominator, x minus 4, x minus 2. I need room because I'm going to have to add multipliers in. So I want to make all 3 of these denominators look the same. So this denominator is missing the x minus 2. So let me multiply top and bottom by x minus 2. And then this fraction, the denominator, is missing x minus 4. So I multiply top and bottom by x minus 4. Let me get my new fractions. So multiply straight across top and bottom. On the top, I now end up with 1 times x minus 2. So it's just x minus 2 over x minus 4, x minus 2, plus 3 times x minus 4 over x minus 2, x minus 4, equals, and then I'm just going to bring this down, 2 over x minus 4, x minus 2. Now that I have the same denominator, if the bottoms are equal, the tops must also be equal. This must also be true for the tops. So I can now take just the top with the equal sign and solve. I'm probably going to unsuccessfully put this on the rest of the paper. We're going to try. So I've got, let me keep parentheses around this for just a moment. Actually, that's not necessary. I'll drop them. X minus 2 plus, we're going to bring this down, 3 times x minus 4 equals 2. This is my equation. The denominators are now gone. So remember, you can drop these at this point. So we have an equation to solve. First things first, I can distribute this 3 into here. I now have x minus 2 plus 3x minus 12 equals 2. Next, we combine like terms on the left side. I've got 2 x terms, and then I have my constants. Those can be combined. So that's going to leave me with 3x, and this is a 1x. So 4x, and then negative 2 minus 12, that's negative 14, equals 2. I might fit this on a page, we'll see. I'm going to bring that over, 4x minus 14 equals 2. I'm going to add that 14 over here. (4x) equals 16. Divide by 4. I guess the grand finale is going to have to be on a Post-it note. That's okay. I almost made it. Okay. These are going to cancel. X equals 4, which is not allowed. Since I have that x can't equal 4, that will give me a no solution when I plug it back in. This answer is actually no solution. All right, next side, we are done with the fractions, at least those fractions. Now we're diving back into the more recent material. Hopefully this stuff feels a lot more familiar. You just took this test. Number 13, use the change of base formula to approximate log base 8 of 220 up to 4 decimal places if needed. So, change of base formula, that's something you do in your calculator. Let's set it up first. It's a log divided by a log. And I always say high over low. These numbers are always written in a way where one is written higher than the other. So 220 over 8. High over low. And it doesn't matter which one's bigger. That has nothing to do with it. It's just how they are written. And this is up to 4 decimal places, so I'm anticipating I'm going to have to round. Reminder, you do have to show this work to get your full credit. So we have log of 220, don't forget about your parentheses, divided by log of 8. 4 decimal places. We've got 2.59, then we got a 3 and a 7. So 7 is decimal place number 4. The next number after it is an 8. And remember, 5 or higher, we're going to go up. If it's less than 5, then we don't round up. So we're going to round this 7 up to an 8. 3, 8. Let's repeat that for number 12. Change of base formula, it's log over log, and it's high over low, 16 over 2. The base, the lower number, always goes on bottom. And this one is actually very nice. Log of 16 divided by log of 2. And you get 4. No need to round here. All right, log and exponential equations. I know how much we all love these. These really aren't bad, but you know, there's a bunch of types to be aware of, so you just have to be paying attention to what kind of problem you're trying to solve. So number 15, 7 to the x minus 2 equals 343 to the x plus 4. First, identify what this is. This is an exponential equation on both sides. We've got exponents, and there's no logs. When you have exponential, there are two ways to solve. You can get the same base and solve, or you can switch the form. What you do depends on the problem. Same base doesn't work every time. Switching the form always works, but there are problems. This is one of them, where it's very complicated to switch the form. So on problems like this one, you'll want to do the same base. So when you get the same base, you want to break the numbers down as small as you can. Now the 7 can't be broken down anymore. Its only factors are 1 and 7. So we know our base has to be 7. Let's use that to our advantage. So we have 7 to the x minus 2 equals, if we know the other base has to be 7, let's start there. It's going to be 7 to something. We don't know yet. We'll figure that out in a moment. And then bring down the x plus 4. Now let's go on our calculator and figure out what this exponent is. So we have 7, hopefully you know 7 squared is 49. Get that out of the way. Let's try 7 cubed. And we're going to keep going until we find our number. Thankfully, we didn't have to go very far. So our answer was 7 cubed is 343. So we need to replace it with that. Now, we have to take care of these exponents. So let me rewrite this one more time. 7 to the x minus 2 equals 7 to the, we multiply 3 times x plus 4, set it up as a distribution problem. Now that I have the same base and my exponents are taken care of, I can drop the bases and I just solve this equation here. So I have x minus 2 equals 3 times x plus 4. I'll go ahead and distribute 3x plus 12. And then I solve. I have 2 x terms. I'm going to move the smaller one, so minus x on both sides. Negative 2 equals 3 minus 1. That is just 2x plus 12. 2 more steps to solve. Going to move the 12 over here to get 2x by itself. So minus 12 on both sides. And I'm going to have to come over here to finish. Negative 2 minus 12 is negative 14 equals 2x. One more step. Divide by 2. X is negative 7. Exponential problems can accept any kind of answer, positive, negative, or a 0, so you don't have to check, but if you want to, be my guest. Number 16, we got another one of these. 1 over 6 to the 2x equals 1296 to the x plus 3. Again, these are both exponential, so these are your two options. Switching form would not be recommended, and again, the reason why, and it's the same for both, is we've got 2 exponents. If we only had 1 exponent, so if I just had that, I would switch the form personally. But since I don't have that, don't do it. It's going to be too complicated, more complicated than it needs to be, I should say that. So again, let's do same base here. So first off, let's take care of this fraction. Now reminder, a fraction is the same thing as a negative 1 exponent. So I can rewrite this as 6 to the negative 1, and then I'll bring down that 2x. Now we can break 6 down into 2 and 3, but that's going to get us nowhere. So 6 is my base. So 6 to something, we'll figure out what it is in a moment, equals x plus 3. So again, let's experiment in our calculator till we find the right number. 6 squared, I hope you already know, is 36. 6 cubed is 216. And again, we're trying to get to 1296. 6 to the 4th, that's my number. 6 to the 4th is 1296. So that is what I was wanting. Now before I drop, I have to multiply these exponents first. So I get 6 to the, that's just going to become a negative 2x equals 6 to the 4 times x plus 3. And now I can drop and solve. And I'm going to run out of room pretty quickly, so I'm going to go ahead and start up here. I've got negative 2x on the left side equals, I'll just write it out. I can distribute it in a moment. 4 times x plus 3. And then I solve. So I've got the negative 2. And then I will distribute that 4. So that gives me 4x plus 12. 2x terms. Reminder, a lot of you like to do this, and a lot of you don't do it correctly. You'll move the 2x, the negative 2x, since it's smaller, yes, but it's by itself. Please don't move it. I see too many mistakes still with that. So since this is by itself, I will move the 4x. And if it makes you feel better, either way I do it, I'm actually going to save myself one step by doing it the way I'm doing it right now. So it's actually better that I do it this way. So we're going to subtract the 4x. Yes, we'll get a negative. That's okay. Negative 2 minus 4, that's negative 6x equals positive 12. And then we divide by negative 6. X equals negative 2. And again, exponentials don't have to be checked, but if you want to check, go right ahead. Number 17. Log base 6 of 8x minus 4 equals 2. This is actually my favorite type of problem because there's only one way to solve it. So we have a log on one side and a number on the other. So we call that the log equals number case. There is one way to do it, and you switch the form every time. So currently it's in log form. I hope you can see that. We want it in exponential form. Base stays base, the other two switcheroo. That's the name of the phrase. That's how this works. My base is 6. So in exponential form, the base is big. So it's a big 6. Base stays base, the other two switcheroo. The 2 is going to come over here. And the 8x minus 4 will come over here. So this becomes 6 squared equals 8x minus 4. So you have to know how to write it too. That's just as important. Like you can know the phrase and know which numbers go on which side, but you have to know how to format it. So exponential, we have our base with the exponent, and then whatever's left just goes on this other side by itself. From here, it's just algebra. 6 squared, 6 times 6, that's 36, equals 8x minus 4. I will move the 4 over here so that we can get 8x by itself. 40 equals 8x. Divide by 8. And we get 5. Now these are the problems that don't necessarily have to be checked because of how they're solved. So we don't typically see no solution on log equals number, but if you want to check just to be extra sure, we can definitely do that. So we have, and when you check, reminder, we are only checking to see if the solution is allowed. We're not checking to see if the answer is correct because that requires a little more work than we'd like to do. So we're just checking with a regular log, no special base, just a regular, like the calculator likes. And then this is 8 times 5 minus 4. And we just put that in and make sure we get an answer, something that is not domain error. So we have log of 8 times 5 minus 4. And just make sure you get an answer, which we did. So it passes, we're good. Number 18. Log base 1/5 of x equals negative 4. Same type of problem. This is log equals number. So we will switch the form. So we're currently in log form again. We want exponential form. Base stays base, the other two switcheroo. So our base here is 1/5. And for exponential form, we're going to make it big. -4 is going to go over here, and x is going to go over here. So 1/5, and since it's a fraction, put it in parentheses for when you type it into your calculator, to the -4th power equals x. Here's the wonderful thing about this problem. X is already by itself, so once I get what this answer is, I am done. And this will be nice. It doesn't look nice, but it is. Calculator. So I have 1 divided by 5. You got to put it, delete. 1 divided by 5 in parentheses. That is important. And then I'm raising it to the, I don't have to put this in parentheses, but I went ahead and did it anyway. -4th power. 625. And this check is very easy because the only thing you plug in is x, and x is positive here, so we are good. There we go. Number 19, 1/32 equals 16 to the x minus 8 power. Now this is exponential. You have to look a little closely at it. I'm going to flip this problem around because most of us are used to seeing this on the left side, so that might be tripping you up. So we have 16 to the x minus 8 equals 1/32. I hope that helps. So now that it's written this way, we can clearly see we have an exponential. Our base is 16. This is our exponent. And remember, with exponential, you have two options: same base or switch form. And since we only have one exponent in this problem, this is a problem where you can switch the form if you want. You could also get the same base. That wouldn't look bad on this problem, but it is more work. So I'm actually going to switch the form here, but either way will still work. So this is an exponential form, and I want to put my next step into log form, so I'm going to keep that in mind. So this is going to be log. Base stays base. My base is 16. Remember, it's small in the log form. The other two switcheroo. And since I have a fraction, I definitely want to put that in parentheses. And that equals x minus 8. From here, I can now put the left side in my calculator. That's what makes this method so nice. This is change of base formula. So remember, it's log over log, and it's high over low. So this is a case in point. The 1/32 is smaller, but it still goes on top when I do the division. So I'm going to put that in my calculator. And this will actually be a nice number, if I recall correctly. Yeah, this is nice. Okay, log of 1/32 divided by log of 16. Just negative 1.25. Nothing we can't handle. I do want to mention, because I've seen it before, when you get a decimal that's this small, do not round it. Use the whole thing. We only round when we feel like we have to, when the decimal is too long to use. One step and we're done. We need to get x by itself, so we'll add the 8 over here. X equals, please do this in your calculator, subtraction is not clean with decimals, 6.75. And this is exponential, so you don't have to check unless you want to. Number 20. Log base 3 of x plus 4 plus log base 3 of 5 equals 3. Before we do anything, there are 2 logs on one side. That is never allowed. So we have to condense to 1 log. And wherever you condense, you have to check, no matter what type of problem it is. I found that condensing can sometimes give you a no solution, so you do need to check for that. When you condense, the very first thing you look for are numbers in front of the logs. These are exponents, if you have them. Now, thankfully, in this problem, that is not going to be an issue. So next thing we do is we look at the plus in between the logs. This tells me what to do. Plus means multiply. If I had a minus, then I would subtract. So just keep that in mind. We're going to condense this down to 1 log. So this is now log base 3 of 5 times that. I'm multiplying these two. And since the order doesn't matter here, I'm going to move that 5 and put it in front. Now I can identify what type of problem this is. This is log equals number. And log equals number is solved one way, and that's switching the form. So right now, we are in log form. So my next step will be an exponential form. Base stays base. My base is 3. It is a big in exponential form. The other two switcheroo. So this 3 now is my exponent. So this is 3 cubed equals 5 times x minus 4. 3 cubed, that is 27. 3 times 3 times 3. Equals, on the right side, I can just distribute that 5. 5 times x, that's 5x. 5 times negative 4, that's negative 20. And then I just solve for x, 2 steps. Add 20 to both sides. That will give me 47. And, oh, I'm looking at my key. Thankfully, I have made a mistake. Let me go back and fix it. This is supposed to be 5 times x plus 4. So let me just follow that mistake. So now I'm going to subtract 20 instead, since it's a plus. Very easy mistake to make. My apologies. So 27 minus 20, this is actually just 7. Okay. Hopefully you were able to follow that. I miscopied the sign, followed it through, and now I'm on the right track. Bring down the 5x, and then divide by 5 on both sides. X is equal to 7/5. Nothing wrong with the fraction, so please leave it. And then if your answer choices happen to be in decimal form, well, you can easily put that into a calculator to get your answer. 7 divided by 5 should be 1.4. Yes. So if you're given decimals instead, then obviously you'll want to find the decimal. All right, last page. We have 4 more equations, and then the word problems, and then we're done. Number 21. Log base 2 of 2x plus 6 plus log base 2 of 5 equals log base 2 of 50. First off, we have 2 logs on the same side. That is a no-no. So first and foremost, we will condense. And when you condense, you must check. I'm going to pause here real quick. I just realized that I wrote this already onto the problem, but I never checked. So let's go back to 20 real quick. I'm going to set a good example. I do need to go back and check this answer real quick. I totally forgot that I wrote that. So checking, we just find any logs that have letters in it. We have 1. So I have log, don't worry about the base 3. The base doesn't matter. Of 7/5 plus 4. Now remember, logs like positive numbers. So it doesn't matter what this number turns out to be. What matters is what sign is on it. Also, it doesn't like zeros. So if you want to think logically about this, 7/5, we already know that's 1.4. We just did that a moment ago. And if I add 4 to it, I'm going to get 5.4. if I plug that into a log, it's going to work. It likes positives, but if you don't believe me, we can certainly plug that in, and we get an answer. So, there we go. All right, now let's go back to 21. So 21, we got the same type of problem here. We have to condense, and when we condense, we have to check. So let's do that first and foremost. First, on the left side, we're going to look for numbers in front of the logs. We don't have any, so we do what the operation is, and that is multiply. So we're going to multiply both of these. Log base 2. Again, I'm going to put the order the opposite direction. 5 times 2x plus 6 equals log base 2 of 50. Now that I've got one log on both sides, I can label this as a log equals log problem. So log equals log. You solve it by, you drop the logs and solve. And I've already written it once on this problem, but this type also requires a check. These will produce no solutions from time to time. So 2 reasons why I should check this problem. Okay, now that I've got the same log on both sides, I can comfortably drop and solve it like a normal equation. And to save me a step, I'm going to go ahead and distribute up here. So this gives me 5 times 2x, 10x, plus 30 equals 50. 2 steps to solve. Minus 30 on both sides. 10x equals 20. Divide by 10. X is 2. And then, of course, we must check. Make sure our answer is allowed. So again, find the log that has letters in it. There's only one of them, so we only have to check log of 2 times 2 plus 6. Again, you don't have to necessarily plug this into the calculator. If you think about it, this will be positive. 2 times 2 is 4, plus 6 is 10. But if you're superstitious, or you don't trust your mental math quite yet, you can always plug it in to the calculator. Log of 2 times 2 plus 6. There we go. So we got an answer. It passed. That's it. 22. Log base 3 of x squared equals log base 3 of 5x plus 66. This is a log equals log. No need to condense. And again, where we have log equals log, we have a check. Okay. So, since we have log equals log, right off the bat, we can drop both of these. We now have x squared equals 5x plus 66. We have an x squared and an x term. When you have that, there is only one way to solve. Get everything to one side of the equation, 0 on the other, and factor. You can't square root, you can't divide by x, those are not options. Since x squared is comfortably on the left side and positive, we are going to leave it there, move both of these over here. You can do this in one step or multiple steps. The choice is yours. I'm going to do it all at once. So minus 5x and minus 66. That's going to be 0. These are not like terms, so you can't actually subtract any of them. We're just going to write them all out together. Here we have a trinomial, 3 terms, no number in front. That is the best kind. So we're just got to find our factors. I'm a little squished here. So we just need an A C B chart for that. A is 1, C is negative 66, B is negative 5. 66 has a lot of factors. We've got 1 and 66. That's clearly not going to be it. It's even, 2 and 33. 3 can go in there. I'm going to bring out the correct pairing and one of the more obvious pairings, 6 and 11. Six times 11 is 66. We need a negative, so one of these has to be negative. And to get minus 5, that means the bigger number must be minus. 6 minus 11 is negative 5. And 6 times negative 11 is negative 66. So we're good. So we have, since I'm going to need more room for this, I'm going to put this first. 6x minus 11, x plus 6. Those are my two factors. Last but not least, to solve, I have to split and solve. I've got x minus 11 equals 0 and x plus 6 equals 0. Since I'm out of space, I'm just going to jump to the answer. I hope that's okay. Add 11 to both sides. X is 11. Subtract 6 from both sides. X equals negative 6. So we're basically just flipping over the sign. Now we definitely want to check. We've got two answers, and a lot of times those turn out to be no solution problems. And we also got a negative, so we definitely want to check that. So check both of them, and we've got 2 logs. So we're going to check 4 logs total. Let's start with the x equals 11. We've got to check it into both of these since they both have letters. We have log of 11 squared and log of 5 times, I'm going to write the 11 in there, 11 plus 66. Now, if you think about it, these are definitely going to be positive numbers. But again, you're always welcome to plug it into the calculator. Log of 11, let me retype that. Log of 11 squared, it passed. And log of 5 times 11 plus 66. We're good. So x equals 11 is an answer. Now let's check x equals negative 6. We have to check both of them. And we're going to do the exact same ones, just a 6, negative 6 instead of 11. Log of negative 6 squared. Here's where the parentheses are really important. If you do not type the parentheses into your calculator, it will read it differently, and that will not be correct. So we have log of negative 6 squared, parentheses. It works. Remember, squaring a negative still makes it positive. And log of 5 times negative 6 plus 66. Log of 5 times negative 6 plus 66. Good. All right, it passed both checks. So these are both correct answers. X equals 11 and x equals negative 6. Those are both the correct answers. All right, 2 more equations. 23. 1 over 625 to the x power equals 125 to the 3x plus 1. Here we have exponential. Remember, there are 2 ways to solve. Same base or switch form. When you have 2 exponents, count them, 2 of them, you do not want to use switch form on this problem. Again, it makes it far more complicated than it needs to be. So we're going to do the same base. Now, as you can see, these numbers are both quite big, so finding the base is going to be a tad difficult. Let's start with the smaller base and then go from there. I will go ahead and turn this fraction into the exponent form to make my life a little easier later. So we have 625 to the negative 1 to the x power equals, and then in a moment I'm going to figure out what this base is. And then once I find one base, I have the other. So that's why we start with a smaller number. It makes my life just a little easier. So I've got 125. Now the good news is breaking this down does not take long at all. 125 has an obvious factor, and that is 5. Ends in 5 or 0, you can divide by 5. So we can break this down into 5 and 25, and then 25 only breaks down into the 5s, and that's it. So yes, we had to do a little bit of work, but not much. So 125 is the same thing as 5 cubed. So that is what I'm going to replace it with. Now I need to make this base the same. Well, this ends in a 5 as well, so we can pretty confidently say we can get these to be exactly the same. So I'm going to do this process again. Now, I know it's 5 to the something. We know that much. And then when I get this exponent, I'm going to multiply it by that -1 that's already there. I can't just pretend it's not there. So I got to keep that in mind as I go. All right, 625. Let's figure out how many 5s it takes. So we know that 5 cubed is 125. We've already seen that. Let's try 5 to the 4th. 5 to the 4th is 625. So 625 is the same thing as 5 to the 4th. We still have to multiply it by that -1, and we still have that x on the outside. Equals 5 to the, I'm going to go ahead and multiply these together. 3 times 3x plus 1. So now, if I multiply my exponents on the left side, I have 5 to the -4x equals 5 to the, I'm going to go ahead and distribute, save myself a step later. 3 times 3x, that's 9x. 3 times 1 is 3. Now I finally have the same base. I can cancel these out and I can just solve. And I'm out of space, as you can see, so I'm going to come over here and finish the problem on a post-it note. So, drop the base and solve. -4x equals 9x plus 3. 2 steps. Minus 9x on both sides, since this is by itself. You don't touch it. It stays there. Subtracting, we get -13x equals 3. And then lastly, we divide the -13 off of the x. X equals -3/13. The negative can go on any part of the fraction. And I can about guess this is not a pretty fraction, or a pretty decimal, let me see. 3 divided by 13. Yeah, no, it's not pretty. So, fraction form for sure on this problem. So, x equals -3/13. Exponentials do not have to be checked for no solutions, but if you want to check to make sure you did it correctly, be my guest. I'm going to recopy this answer onto the page, but I'm going to have to move the post-it note so that we can do the next problem. So my final answer here, x equals -3/13. Last equation, we can be excited about that. Number 24, and this one is not bad at all. Log base 1/9 of x equals -3. This is my favorite, the log equals number, and it's my favorite because there's only one way to solve it, so we don't have to think about that. We switch the form. As you can see, it's in log form, so I need to put it into exponential form. And we remember how this goes. Base stays base, and it becomes a one big base. Since it's a fraction, I'm going to put it in parentheses. Base stays base, the other two switcheroo. So -3 is now my exponent, and x is over here. And what's beautiful about this problem is once I put this in the calculator, I am finished because x is by itself. So calculator to get our answer. Parentheses around that 1/9. And then we raise it to the negative third power. 729 it is. And we're done. And if you want to check it, this is very quick. 729 is positive, so if I plug that in there, it works. No issues there. Okay, last two problems, or three problems. Now these look like they're going to take a while. They will not. 25, how can you tell if a function has exponential growth or decay? This is just testing your understanding of the concept. Clearly on the benchmark, you won't have to like write out an explanation, but if you can explain it, then you're good. So let me give two quick examples to show you the difference in case you don't remember. The difference is very easy to tell. So if we had y equals 2 times 1/3 to the x power, and then y equals 1/2 times 5 to the x power, you look at the number inside of the parentheses. The 1/3 is less than 1, so this is decay. It's going down. The 5 is more than 1, so this is growth. It's going up. That's it. So let's write that out in words. I'm going to put that up here so you can look at it while I write. So how can you tell? We look at the number in parentheses and if we have the formula down here, it's all of that together. So I'll add that little detail. It's the 1 plus or minus r. This is the equation that this comes from. By the way, I know the letters are a bit different, but the concept is very much the same. So it's whatever's inside of here. We look at the number in parentheses. And then, this is an English class. I'm going to do this very just quick to the point. This is not a complete sentence, but, you know, I answer the question. Okay, so we have two options. 1, if it's bigger than 1, that equals growth. Option 2, if it's less than 1, that is decay. That's the gist of it. That's basically what I just explained to you on the post-it note here. It's less than 1, it's decay. Bigger than 1, it's growth. So that's really what I wrote here. So again, very straight and to the point. Okay, 2 more problems. Exponential story problems. For each problem, set up the formula and solve for the indicated value. Use a to the t equals a times 1 plus or minus r to the t power. So let's do a quick refresher on what all of these letters mean before we start. I'm going to go ahead and answer these now before I fill in the others because I'm going to need some space. So big A and little a, they are very easy to confuse. So big A, this is our starting or our ending value, like yeah, your final amount. That's the best way to put it. So A is for amount. And I like to refer to these as a before and after. So this would be the after. And I don't know why, but like this makes sense to me because like after has the letters A and T in it, and this is A of T. And then A is your initial amount. And I use the word initial because you will literally see that written in plenty of problems. It will say initial amount verbatim. But initial means starting amount. So this is the before. This is before it undergoes growth or decay. So think of these as like before and after. It starts small and then it gets, after, it's a big A now. I don't know. Okay, R and T are very easy. R stands for rate. And reminder, this has to be written as a decimal. So every problem I've seen, this rate is given as a percent. You have to change it to a decimal. T just stands for time. And in this exact equation, it is in years, always. So that'll make this a bit easier. 26. A coin had a value of $1.17 in 1995. Its value has been decreasing at a rate of 2% per year. Write an exponential function to model the situation. So far, we're given R, that's the rate. So R, and it's been decreasing at 2%, so minus 2%, and then we have to change that to a decimal. So we're going to add a decimal point at the end of the number and move it 2 to the left. That's the rule. So we're going to get a 0 in here. So let's rewrite that as a minus 0.02, no percentage. And then we have to figure out what the other number is that they gave us. Because right now they've given us only 2 of the numbers in here. So we can just write a basic function. Then we can actually answer the question once we get to B. So you have to figure out what this 117 is. So the wording can be a little difficult to understand with this. Is this my starting or my ending value? Now it's saying that we had a value of 117. So the had implies before. And it also says it's been decreasing at a rate of 2% per year. So that means that since then, it's been decreasing. So this is our before value. We're going to be finding the after. And if you had to go down and read B to figure out that that's what it is, that's fine too. Because B is going to tell us how long it's been. So clearly, we're going to see the new value after time. So all the more reason to say that is our A value, our little a. So, turns out we have A. It's $1.17. So again, just kind of ask yourself the question, does this amount seem like a before value or an after value? So once you read enough into the problem, you'll kind of figure that out. So let's fill in what we have into this equation up here. A of t equals, we know little a is 117 times 1, we decided this was minus 0.02 to the t power. Now this is not the best equation. The best equation is where you simplify inside the parentheses. That's how it will look in like a multiple choice setting. It will never be written like that. A of t equals 1.17 times 0.98 to the t power. So this is my function. Answer. Find the value after 6 years. So now we're given a time. T is 6. So now we can fill that in this equation that we've already partially set up and figure out the new value. That's going to be the A. And again, A after, just even more reason to know that we're looking for big A. We don't know. So now we can say big A of t is unknown. That's what we're looking for. So let's take our equation. Big A of t equals 1.17 times 0.98. We now know that t is 6. And so A of t is by itself. We just need our calculator to tell us what our answer is. This will clearly be a decimal. Type it in exactly as it's written there. 1.17 times 0.98 to the 6th power. And since this is money, we will round out to 2 decimal places. They didn't give us any directions beyond that, so that's what I'm going to go with. 1.03, the next is a 6. We will bump this 3 up to a 4. So $1.04. after 6 years. That's how much this coin is now worth. We have one more of those and we are done with this study guide. A college with a graduating class of 2,500 students. I know that'll be important. I don't know what yet, but I will in a moment. In the year 2010, predicts that its graduating class will grow, so that's going to go up 7%. That's my rate per year. So we have to write the function, and then we'll be able to give an answer once we get to part B. So we are clearly, again, given the rate. They pretty much give you the rate pretty much all the time. Will grow, so that means it's going to go up, plus 7%. Again, we have to turn that into a decimal. 2 places to the left, we'll get a 0 in there. So this is plus 0.07. Now we just have to figure out what this 2,500 is. It's clearly not time in years. It's going to be the before or the after, the big A or the little a. Now let's read the context again. A college with a graduating class of 2,500 students predicts that its graduating class will grow 7% per year. So that means we're taking this number and we're going to see how it changes in the future. They're thinking it's going to get bigger. So this is our starting value. So this is our little a, as it turns out. Again, just ask you up, does this sound like a before or an after? Well, they're saying that it's going to get bigger, so this is more than likely before. All right, now we fill in what we have into this equation up here. So I don't have big A of t equals, I do have little a, it is 2,500, times 1, we have figured out that this is a plus 0.07, and then we don't know t, so to the t power. Again, the better equation is where we simplify inside our parentheses. A of t equals 2,500 times 1.07 to the t power. B, how many students will be graduating and will be in the graduating class of 2020? So, we are given a time, and then they ask how many students will there be. So A of t, again, is what we don't know. That's what we're figuring out. Now be careful here. Don't plug 2020 into t. It has not been over 2,000 years, okay? We have not been going to high school as a human population for over 2,000 years. Just hasn't been happening. So remember, the first number was in 2010, and now it's asking how many will there be in 2020. So quick math, how many years has that been? 10 years. So think about that. Don't just straight up plug it in. So t is 10. Let's plug it in here. A of t equals 2,500 times 1.07 to the 10th power. So let's plug that in. 2,500 times 1.07 to the 10th power. Rounding. So this is an interesting question. It genuinely depends on who you ask. If we're going to get technical, when you're rounding people, animals, living things, you never round up. You always go with the whole number, and even if it's a little over or a lot over, you don't round up. So that's always been the guideline I've gone with, so this would be my answer, 4917. On the other hand, we are just trying to get an approximate number, and when it's that 0.8, most people are comfortable saying, okay, roughly 4,918 students. Again, we are rounding here, so this isn't even an exact answer, and this is just a very educated guess on how many students there will be. So being off by 1 student is not a big deal. So I'm going to stick to my rule and say 4,917 students, because that's how you round people. But if you were to have this, like especially in a multiple choice scenario, and your answer choices, I would probably guess it would say 18, not 17. They would just round to the whole number. So I'll put both as answers. How about that? So it just depends on who's writing the question, honestly, because we could go back and forth on this. I would say that you could have reason to say that they're both correct. So I'll put both down. As long as you can get that answer, the answer I got on my calculator, we are good. All right, students, that is it for today's video. Hopefully this answered any and all questions that you had about the benchmark coming up. If you have additional questions beforehand, feel free to email me or come talk to me in person. Otherwise, I hope you have an awesome day. Bye.